Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyxel Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Hi, and welcome back for another podcast. And in today's podcast, we're going to have a little bit more in-depth information into some Wi-Fi problem solving.
Yeah, we talked about in an earlier podcast how to upgrade your Wi-Fi 5, 6 system into a newer technology. But maybe today is good for a little bit different angle before you move into the new technology.
Yeah, I think so. And today we brought our resident Wi-Fi expert back in again. Hugh Simpson, welcome back.
Welcome, you.
Thank you very much. Good to be here.
So I think we'll start off with saying that, you know, we want to look at these technologies apart, which is the Wi-Fi 5, Wi-Fi 6, Wi-Fi 7. Okay, there's always a need for this change to improve the technology, to leverage from the new standards, okay? But one of the common things that we often hear is, okay, I've replaced all this new technology, but it's not actually fixed my problem.
Yeah,
okay.
Yeah, and that's a thing that we need to fix.
Yeah, and
first, before we move to a newer technology.
Yeah, so it's understanding where those problems lie. So technology shift, you know, from Wi-Fi 6 to Wi-Fi 7 has technologies in it that do improve Wi-Fi and improve the efficiency, but there are often underlying issues in Wi-Fi deployments that need to be addressed, and I think that's what, you know, the aim today is, right?
No, absolutely. We take a look at some of these problems that we see out there, you know, things like CCI, airtime congestion, client limitations, sticky clients, coverage versus capacity. These are all important, right?
Yeah, and then also there's the backbone part, right? You know, like, you know, the other elements outside of Wi-Fi, right, which is like the backhaul, the bottlenecks in the network itself, the wired network constraints, you know, the change obviously I'll touch on it slightly, but the change into multi-gig, right? When we went past the 1 gig mark, multi-gig became, you know, and lots of people didn't take that leap in the switching, right? And then obviously then you've got the internet bandwidth themselves, right? And the constraints there. So
Yeah, and let's not forget DHCP and DNS as well.
Oh yeah.
Yeah, it's a common
always DNS.
Common fault, yeah.
Always DNS.
Yeah.
Okay. So I guess let's start with a few of those top level, you know, those problems that you mentioned there, right? You mentioned CCI, co-channel interference, right? Well, let's start with that because I think that's quite a fundamental part of Wi-Fi, which people often, I would say, misunderstand, or, you know, a lot of people, they go, oh, we haven't got the coverage or we don't have the capacity. So they just add more APs, right? Creating more of the problems, or there are other problems in the airwave, right? That's caused,
No, absolutely. And one of my sayings is, you know, I'd rather have no Wi-Fi than bad Wi-Fi, and co-channel interference is what I'm talking about, right?
Yeah, absolutely,
so, you know, it's something we all have to live with. Wherever you are installing wireless, it's either introduced by other devices, other, you know, not even necessarily Wi-Fi, but other noise on the channels and on the frequencies, or indeed by ourselves. And again, throwing more access points into an environment actually just creates and increases this co-channel interference.
Yeah, and I see also that people want to have more speed, then they make the bandwidth bigger, but the number of channels are
just not there, right?
are not there.
That's still the same, right? So unless you do move to that Wi-Fi 7 and the 6 gigahertz, which gives you that extra frequencies and channels availability, then that can certainly help with co-channel interference. But fundamentally, it is still there.
Yes.
Yeah, so you end up with that, you know, all those, even the APs competing for airtime, right? And I think we'll talk about, because you mentioned airtime in your list there. So we'll come to the airtime in a bit more, right? Like we said before, when you start densely packing these APs into space, whether it is for coverage or whether it's for, you know, getting more clients in there, part of that whole process is to understand how they're going to work coexistently together, right, without creating all the problems. And I would say that, you know, when you're looking at sort of our technologies from our secure cloud networking platform like Nebula, we have things like Wi-Fi Health, which has AI functionality in it, but that gives you a really good understanding of what the client devices is experience. It can visualize it and show you, and what the AP is receiving. So it gives you like a graph to say where things are not performing and where are. It gives you an indication of that co-channel interference, right?
Yeah, but also the neighborhood scanning that we have implemented in Nebula is a good tool.
That's a new
sort of-
feature, right?
That came in January.
It's quite new,
It's good.
and it's very helpful as well. Yeah, particularly you can do a scan on each individual AP. Yeah, so that's a great tool to identify your network.
And of course, at the top of our list is our smart antenna technology, which is
That's a good solution.
our dynamic antenna. So if you are in a co-channel interference prone environment, whether it could be a densely populated area, where you are serving thousands and thousands of clients, then in that case you will need to pack the APs close together to take the load, right? And smart antenna allows us to dynamically allocate radio patterns to each device. I think we even did another podcast on smart antenna.
We have done, yes.
Yeah.
Absolutely.
So, but the technology allows us to, where we don't have control over somebody else's radio, it allows the access point to move away from it, and also dynamically work in that environment with other access points, including our own, right? In fact, we don't really need to do any of that automatic power management. We can let smart antenna do a lot of the work.
Yeah, and it really helps in those dense environments where you do have a lot of noise level. Like I say, noise might not just be coming from your own access points. It might be coming from your neighbouring access points in other buildings, in other companies, etc., all around you. You just cannot get away from it.
Yeah, so I mean, if for those customers or those people who don't understand about our product line, the access points, they end in an S to signify that they are a smart antenna product. So not all products have smart antenna. Again, we did a whole podcast on the difference between a static antenna, dynamic antenna, and dual mode antenna that we have. So if you're really interested in that side of the technology, because we're not going to dig deep into that for sure in this, it's just that is a very important part of the technology in our portfolio that helps in this co-channel interference and high density deployments.
Yeah, so let's talk about some airtime. We talked about it, we kind of mentioned it. It's again another problem that we see within wireless environments is this airtime congestion.
Well, I mean, what would be a good analogy for that?
A good analogy would be, hey, I've got a full tank of fuel in my Ferrari, but I'm stuck behind a tractor, right? And that is the airtime congestion that, it's as simple as that,
And be aware, Wi-Fi is a shared medium, yeah? So everyone should gain their own time to get the data through, yeah?
So, let's step back a little bit for people who don't understand, I would say, about the airtime, right? So imagine you're in a room and the access point can only talk to one person, or the teacher can only talk to one person at once, right? They talk to you, they get a response, you talk back to them, and then they move to the next person, and then they go around the table. This is how the Wi-Fi is essentially shared out, right?
Should work.
Yeah, in theory.
But as we know, in a classroom environment, all the children speak back at once. No one can hear anything, and the whole thing breaks down.
Yeah,
right.
Correct, yeah.
So, in a very well-behaved classroom where one person is speaking to one person at any one time, it's great.
So management is needed.
Yes, exactly.
Yeah.
But do more streams actually become important, or?
Yeah, absolutely. You know, and again, with Wi-Fi 7 access points, we're now seeing the increase of streams. Our top WBE 660S supports 12 streams. So potentially that means it can talk to 12 devices at any one time, or it can speak to a few devices with a lot more bandwidth, right? So again, it allows us to utilize the speed, but also deal with far more clients.
Yeah, and I think we'll talk a little bit about client limitations and understanding clients connecting to Wi-Fi, because that's also important, but we'll come back to that in a minute. But what's also interesting is if you want to see like how airtime is actually being used in your access point or in the air, again, Nebula, our secure cloud networking platform, again shows you that airtime fairness, functionality is in there, and also can show you the channel utilization in the dashboard, showing you a very quick way of looking at where the utilization is and how you can potentially improve it yourself. Also, we have airtime fairness settings to allow us to be a bit more automated in that approach. And like I said before, even in the co-channel interference, the Wi-Fi health, it can show you the congestion or problems or what the client experience or each AP or client is experiencing. And I think that's one thing that I would definitely say is very important when you want to understand what is the client experiencing. You often have to use pieces of software or all sorts of...
Or calculations, etc. It all comes back to the math, right?
Yeah, but in Nebula, we have a method of understanding what the client is receiving, and we feed that back into the dashboard so you can understand what the client is experiencing, not just the AP. So you see it from both sides, right?
And the thing is that Nebula makes wireless visible.
Yes,
yeah,
absolutely.
That's what you're doing. You make it visible to see what's happening.
Yeah, Michelle, you mentioned it, the neighborhood scanning feature we added in January, right? Also a good way to see what would be affecting airtime. And when we're looking at heavy users that are using video phone calls, downloading, they also degrade the performance for everyone, right?
Yeah, so again, application and the way that people are using the wireless also has a big impact into the airtime. So, not just that we've got lots of clients, right? We just got to understand what applications are happening on your environment as well. And we can see that. Licensing CMP on our access points can actually see that information, right?
Yeah. We have that functionality in our Nebula system. So we can manage the traffic.
Yeah, absolutely. And you can start restricting it, etc., or allowing a certain amount of bandwidth for it. So again, we have that control at trying to manage the limitations of airtime that we actually have.
Yeah. So again, another feature there that could be, that comes from Nebula is CMP, Connect and Protect functionality, which is we can apply some bandwidth management as well of the applications at the edge on the Wi-Fi access point. So very, very nice feature. And then not forget, that as we mentioned at the beginning, we talked about that classroom where we're talking one-to-one. In theory it works, but the application is the bit that makes a mess, right? Because it starts to grab more airtime because it's holding the AP as it does the communication. And then another thing that obviously affects airtime as well is, the client type as well, right?
And the number of clients.
Yeah.
But let's also add in there, again, we are seeing and we have seen over this last year, etc., the standard of clients increasing, right? The Wi-Fi 7 clients becoming more popular, right? We've seen more phones, more devices actually using the Wi-Fi 7 standard now.
Well, even IoT, and I think we should probably touch on IoT a little bit later, because if you are very heavy on IoT devices, they may seem like very small devices, just using a very small amount of bandwidth, but they absorb a lot of airtime unless they are in the newer standards. And we'll talk a bit about in client limitations. But if you are using a lot of IoT devices, a lot of consumable routers, for example, at homes and stuff like that, don't actually have the capacity to take that many clients.
To deal with all those connections. And then if you need the real speed from your laptop because you want to watch video or something else, and you really need some high speed, it doesn't work because your IoT devices take down your network speed.
Yeah, so I mean, if you are a home user and you are thinking about, you've got this many devices, you should actually consider more of a business class access point to deliver those services.
Yeah, you just can't be using the older, lower end access points that we tend to see in these old environments. No, you've got to start using some top end access points to be able to handle the number of clients and the data and the applications that these IoT devices are requested now.
Yeah, I remember looking at some of the lower end routers, not particularly us as a brand, but some other ones, and they I think when you look in the spec, it's like 30 client support or 24 client support, and if you start adding all your IoT devices, you're quickly running over that, right? So yeah, it's an interesting area as well, right? Where and actually we've seen a shift in what we call prosumers, right, moving into business APs to deliver home networks because they've got that many devices,
Yeah, absolutely. It's certainly a shift that we're seeing.
So let's talk about client limitations, because
it's close to what we already discussed. So it's an obvious topic to touch to touch now. Yeah, it's the type of client, but also the number of antennas are quite important. And yeah, the more antennas, the higher speed.
And it's about understanding what your clients are.
Yeah.
So we always have to remember that wireless is two ways. Just because our access point can shout loud,
Yeah.
can shout to lots of users, can our clients, can our devices actually speak back? And this also includes IoT. You know, they're not necessarily built for Wi-Fi first, right? They're built for the application that they're used for. And Wi-Fi is then just an added module in there. So again, you know, let's understand those devices, you know, the 1x1s or the 2x2s, etc. And when we talk about that, that's the number of streams, that's the number of receives and transmits that these devices have. So going back to our stream conversation, the top end has 12 streams, so it could support 12 1x1s or 6 2x2s, etc., and any combination of those as well.
Yeah, so I mean, it's very important when you're doing the planning to understand. If you have an understanding of what devices in your network, then it can really help with the planning of what you're doing, right?
Make your client an inventory of the client that you want to use.
Of course.
That's really important.
Yeah, and also plan for it. You know, when you're doing your wireless site surveys, understand what that client is and how it communicates.
Yeah.
You know, again, when you're walking around with your surveying tools, these are specialized bits of kit to pick up the minutest noise levels. And again, that isn't these clients. So a good example of that is in a warehouse, right? So warehouses tend to be quite complex environments to install, or we believe, or people believe they're quite complex. Mm-hmm. The right design, understanding the access points and the clients, then they become easier. I'm not going to say ever easy, but the only things that really move and change in those environments is where the stock is and what's on your stock shelves, etc. So again, that really modifies. Whereas in hospitality environments, in a hotel or in a stadium or in an open space,
it's a different behavior.
We don't know what's coming in, and we have no control over what is coming into those environments.
Yeah.
So again, although we kind of perceive warehousing's complicated, actually some of these spaces, open spaces, are even worse, right? Because people expect it to work.
Yeah.
Yeah,
that's more important.
Yeah, like you say, in hospitality, which is probably a prime area for where you have no clue what's coming into your environment at all, or how many is going to be in each room at any given time, right? You know, so certainly when I travel with my children, right, there's 10 devices coming with us at least, right? So
isn't that just you, Kevin?
That's just me. Yeah, yeah. They're the kids; they don't have any. Yeah. So, and also, I would say, you know, some of the client limitations or advantages also depends on their evolution of what the device is. For example, you know, you might not think that IoT devices, you know, a lot of them are low-powered devices, but if they do indeed leverage from some of the newer technology, like Wi-Fi 6, Wi-Fi 7. Wi-Fi 6, for example, they could use things like UAPSD, right, for low power management. You know, a lot of medical industry use this mode, right, so that they can keep the battery power on their devices longer. We had a lot of deployments where we needed this for medical,
absolutely.
right?
Yeah, especially mobile phones.
Yeah. And also with Wi-Fi 7, they improved something called the TWT, right, target wake-up time, which also improves airtime when it's in use as well. And that allows it to basically tell the AP that I'm not going to use airtime and be more efficient, right? So it tells the AP not to save time for me, right?
So all about efficiencies in the air.
So some clients, IoT clients, can really make a difference, whereas if you use older generation or something that's just, you know, you even back in using the N standard, right, they really will absorb a lot of airtime.
Yeah, but remember, in warehouses, then people use scanning devices to scan products. Those products last forever. Yeah, they don't have the latest technology, maybe, and they still need to be connected. Yeah. So also that part you need to cover. Yeah.
And again, it all comes back to having the right design and calculations to take this in, and client limitation is part of that calculation.
Yeah, again, you know, we mentioned smart antenna, right? Because this also helps out in this scenario, right? It can improve efficiency in the air for this type of older generation device. So you can bring in a newer generation device that can actually help you support older devices like this. I'm not saying that that's the best way. It's just that is another thing that product can help you with, right? So, and that comes back to kind of the behavior of how a device can dictate the performance in the infrastructure, right? How can you get around that? What can you do, right?
And does that fix sticky clients? Yeah. We've all experienced it, right? We've all seen it. We've all been there.
Yeah.
We've all walked down the corridor, been connected to the first access point and walked under 4 or 5 different access points and still keep being connected.
But before we talk about sticky clients, maybe we should explain a little bit what we...
It's the client that makes the decision about roaming, right?
It is, right.
And that's why we now call it sticky client, because it's where a client connects to an AP and then doesn't roam, right? Correct. And even though it might have a better signal, a better experience somewhere else, it's still going to be sticky, still going to be connected to that original AP that it's connected to, because it's holding and it believes it needs to hold that connection.
Just so we can sort of break it down a little bit, is when you are connected to an access point and you move away from it, you end up coming to the edge of that access point's, I would say, capacity to carry on communicating to you. Like Hugh mentioned, it's a two-way communication. And you need to move to the next access point. There's one closer to you. Like Hugh said, as you're walking down a corridor, you've already passed it, so you should have been moved over. And the AP doesn't make the decision necessarily. You can force an AP to make the decision. Actually, the client holds most of the...
We have allowed the AP to make that decision.
Yeah.
And again, let's be honest, we design our networks and we design our wireless environments to have this crossover. So it does allow a client, if it is roaming correctly, to move from one to the other without any interaction.
Correct. But if you need to force it, we do have functionality in our, Nebula platform.
Yeah, we can steer.
We can steer it automatically. There is cases where you might want to really control the handoff and by basically forcing the AP to only accept certain signal strengths, right? Yeah. I'm not going to go into it because we talk a lot about RSSI in other podcasts, right? And what it means and how it works, right? But basically, you can set some management to basically move from one access if the device doesn't steer by itself.
Yeah, we've got 2 options to think about here. A lot of the modern clients now steer correctly. We don't see this as often as we used to, but we also might want, as you explained, Kevin, to actually steer the client earlier.
Yeah, correct.
Okay,
yeah.
So we take back some of that control. We want to make them steer. The other thing to understand in this environment is the access points do all speak to each other, right? So they're not going to steer you and not going to drop your connection if there is not another access point to connect to, or the other access point is overloaded.
Correct.
Okay.
Yeah.
So let's understand actually within our environments, within a Zyxel
Always try to keep him connected.
Yeah, the APs do speak to each other. There is some intelligence going on at the back end. They're not just independent, but they are running over the network as well.
Yeah, they are understanding, like you say, they're understanding capacity of the AP, how many clients are, airtime, as we mentioned before, and also how far they are away from the device and whether it's worth changing them or not. And actually, we talked a little bit about the Wi-Fi health functionality. The AI part of that actually can be set to move devices when the client is experiencing poor performance, that it can move it to another access point that's probably going to be more efficient for that device. So there is a lot of intelligence, like you say, behind that in the Nebula cloud, allowing those devices to talk to each other, the access points, and allowing us to manage how we move them. And I touched on that about, the client roaming functionality, the smart steering. We have got like different levels, like be more aggressive at how you want to change it in the platform, right? So we have functionality in there to allow customers to make the changes.
Yeah.
Or if you really want to really fine tune it, you can go into the RSSI feature and really.
Correct. Absolutely. We give you those options again, either to keep it simple or to go right down into those configuration levels as well.
I think the smart classroom steering is a perfect example that we have implemented.
Absolutely.
To help you, especially in education, when a lot of pupils move from one classroom to another, to make sure that they stay connected with the proper performance.
Yeah, the load balancing of the clients is really key.
So let's talk about the coverage versus capacity, right? Because there's often a mismatch on what people understand.
Yeah, this has been changing over the years, and certainly all my experience we used to see coverage as being king. But now we far more have changed, and our understanding has changed. And now we look at capacity. We've talked about all the clients above, the sticky clients, the client limitations, the air times. And all of this understanding comes back to capacity. How do we deal with the capacity that we need and the clients need as well? And ultimately, when we look at this, we shouldn't just look at it per AP. We should actually look at it per frequency that we've got. So 2.4, 5 gigahertz, and with Wi-Fi 7 now, the 6 gigahertz as well. And let's understand the 6 gigahertz. You know, there is this kind of, can I just rip out my APs and put new ones in? You probably can. But again, depending upon the environment that you're in, I wouldn't recommend it. I would always want to understand what's going on in the 6 gigahertz. Probably very little indeed, but actually how the environment affects it.
Yeah,
okay.
I mean,
Walls, ceilings, lighting, whatever it might be, that actually has a bigger effect on those frequencies. And
especially because it's a higher frequency. Yeah, like everyone knows that the 2.4 is a lower frequency, great for coverage, but not the highest performance. And the 6 gigahertz may be a good option, but the behavior is different.
It depends where you are in the 6 gigahertz.
Yeah,
exactly,
it does, absolutely.
Exactly.
If you're in Europe and in the UK, etc., we've only got the bottom half.
Yeah, it's closer to 5.
Yeah, but if you're in America, then they've got the whole 6 gigahertz, and that goes right up to 7 gigahertz,
almost,
right?
Yeah.
Which actually, within that frequency, is completely different.
Yeah.
And acts differently, right? So again, we can't just brandish 6 gig as a standard anymore. You've got to go out there and survey it bottom, middle, and high.
Yes, there's some restrictions in Europe versus US. They have, like you said just now, you have the full spectrum, and we only have half of it.
Half's good, right?
It's a lot, but still within that, you still have your channels that you can use, and how are you going to make those available, or what's available, and also how wide you decide you're going to deploy them as well, right? Because obviously you can take a very wide channel so that no one else can use it, right?
Yeah, and let's think about it slightly differently. As we can use cells in an environment. We don't have to have 5 gigahertz and 6 gigahertz broadcasting from every single access point. We might want to separate them to allow better client utilization, etc., in those frequencies, and to hopefully reduce maybe some of your CCI as well.
Yeah, exactly. Yeah. So again, sometimes you're in these environments and you're receiving the signal like we discussed before, and you're thinking, wow, that's full bars and everything like we mentioned at the beginning.
Yeah, absolutely.
Yeah, but actually often overlooked that the AP itself might need the capacity, or the way it's been deployed might be a factor as well. So at the beginning we mentioned, right, you can upgrade the technology, has some improvement. If you have an underlying issue where you deployed incorrectly in the first place, or never accounted for this, or your environment has changed, actually is often the problem as well, then you might need to look at what AP and how it's been deployed as an underlying issue.
Definitely. This is a big consideration.
Yeah.
The tuning part is about how understanding that, right? So we're tuning, the environment, picking the right frequencies, and actually right now we even have the campaign running, Tune Up Your Network, right? Which is whole part of that, right?
And it absolutely, when we looked at that, when you ran that campaign, wireless is absolutely key to part of that, right? Yes, we can allow Nebula to do a great job for us. It's not going to do 100%. And there might be that fine tuning that you really need to do, which we and Nebula allows us to do. So that gives us all the options.
So at the very beginning, we talked about some of those non-Wi-Fi bottlenecks, right? Actually, they become the real issue. The Wi-Fi could be one component. You could replace the access point.
And what we hear is the Wi-Fi isn't working. Well,
exactly.
Hang on a moment. No, the Wi-Fi is perfect, right? You've tuned it. It's perfect. We've got all the power levels, all the channels, all the frequencies.
Everything is there.
Everything is there, but the Wi-Fi is not working.
Yeah.
Well, this is where the wording kind of mixes up. Wi-Fi, internet,
what is
networking.
Is there a bottleneck? Is there something blocking or whatever? Yeah.
Yeah, and it often comes back to actually switching, right? So there's a few things I would mention about switching. One is the PoE requirements.
Yes.
With the new APs, the power requirement goes up. So probably you need to look at your power requirement, but also the speed. Yeah, because now you see that most of the Wi-Fi 7 devices today are moving away from 1 gig.
They're all multi-gig.
And now there are all multi-gig.
Or 10 gigs.
Or even higher. And if you remain on your old 1 gig switch, then and so that could be a really bottleneck.
What you mean with your Cat5 cabling?
But it's a real problem because a lot of people, I would say, they just try to replace like for like in the same places, but they don't replace the switching. They just upgrade the Wi-Fi. But then, of course, Wi-Fi is actually faster than the wire at this point, and they never replace the 1 gig switch. And in our case, and I know some other vendors do the same, if they don't put the right power in on the PoE, the access point will boot and run, but it'll run in a lower capacity mode, right?
Yeah, absolutely. And let's be honest, we've got to remember that finally a lot of this bottleneck, or where the bottleneck is also in the internet. You know, we are starting to see faster than gig internets become available, but it's not everywhere. Right. So again, if the internet is still running slowly, then maybe you can get away with just running 1 gig switching. So you don't have to replace the switches at that point. But note that at some point it will be the next step for you.
Yeah, absolutely. I mean, the infrastructure itself, I mean, a lot of people, they forget because they always blame Wi-Fi is the problem, but actually they all come back to wire at some point, right?
Yeah, and what's on the wire? DHCP and DNS.
And lots of other things.
Yeah.
But again, I mean, it comes back to, you've got this latency issue and stuff like that, could also be caused by network behind the Wi-Fi, right? So there are other components. So by simply just replacing the access point won't give you that faster speed if you don't pay attention to the other things that go around it, the infrastructure, right?
Yeah, it's about fully understanding. I think that's what we've gone through today, a lot of, is trying to understand what's happening in the wireless, potentially what's happening in your network, and what is happening in the application as well. The actual internet itself. Everybody believes that it's click your fingers and it's instant, right?
Yeah.
Unfortunately, as we know, servers get overloaded. Anybody trying to buy a ticket to the latest concert, for instance, will know that you get it put in a queue because so many people are trying to access these services.
Yeah.
So anyway, I mean, that's a lot of information to take on. So I think we should wrap up with a bit of a summary. So I think if we're talking about replacing access points, which we absolutely, to take latest technology is an absolute.
We recommend to do this. Yeah,
of course, we're going to say that anyway. But I mean,
but for warranty, support, new clients coming out, latest speeds.
It's all new tech, but
compatibility.
If you're assuming that just by taking out the access point and putting the access point will just fix some underlying issues, that you need to consider what we've gone through today and understand some of those components or those behaviors in the air and with clients to really understand that am I going to benefit from the upgrade fully? Yes, of course, technology-wise you will do, but if you're expecting to fix other issues that are already there, then it won't do that. They will just migrate to the new stuff as well, right? And also, really consider what goes on after the access point. We have now moved to a Wi-Fi first environment, right? So almost everybody's using laptops or connected to Wi-Fi, but no one takes care of what happens to it when it comes off as much as you would think. And we often come across this problem where you don't move to what you leave the switch. It's been working, it's fine, but it creates a bottleneck, creates an ongoing problem, create other issues in the network. So consider that as well. And for those really challenging environments, of course, you can use our smart antenna technology. For whether it's high density or whether you've got a lot of interference, and that will, I would say, probably give you the best shot in very, very challenging environments. And also all those functionalities in our secure cloud networking platform, Nebula, that allows you to look at the channel utilization, look at the channel widths, some of the client steering, the load balancing, all that kind of functionality is in there to help you. Some of it's automatic, so it will really assist in that day-to-day operation.
Yeah, Nebula and its visibility, as I think Michelle said, it just makes wireless visible for us.
Yeah, because that's always key. That's
especially
key.
when you're remotely, right? If you're a managed service provider, managing lots of customers, you can't see what's going on remotely at 10, 20, 30, or even 100 sites. Yeah. So it helps you really find the issues very quickly. And just on the last bit there, if you are remotely managing it, we do have functionality at Wi-Fi Aid. You mentioned DNS and DHCP, right?
Absolutely, yes.
So that tool allows you to quickly identify clients that didn't get DHCP or don't have DNS or can't see the internet, and that allows you to get to a problem very quickly. I mean, they're one of the most common issues found with client devices. My Wi-Fi is not working. It doesn't really help you a great deal, right? And this is a tool that also...
Yeah, then looking through logs and trying to understand it, and actually it doesn't highlight this.
Yeah, Wi-Fi Aid allows you to see that immediately, how many clients don't have DHCP, what VLAN, etc., or can't see the internet very quickly. So for problem solving, it's a lifesaver. So also another little tool there that's just really cool to sort of help you in those day-to-day operations.
Yeah.
So I think as a last, I started rounding up there, but let's just, so we finish off. If we could take one key thing away for each of us, what would that be? Michelle, what do you want to start?
I think investigate what client type you have to see what is the requirement of your network. So identify the clients.
Do a proper site survey, across all the 3 frequencies. That will really help.
For me, I think, if you're really, looking at all these kind of elements in the network, I think for us, definitely, then all the tools in Nebula, you can leverage all of those to help you identify problematic areas or issues. Even if you've got our older generation APs and you move into the new ones, I think that helps, right? So I think that for me is the key takeaways, and I think there's a lot of information there for people to take away. So, all right, well, I think that wraps it up there.
Yeah, no, we could probably go on for another hour.
I know, I think so.
So thank you for coming in and talk about with us about Wi-Fi again. So thanks for that.
No, thank you very much.
Thank you.